Hello everybody, Dr. Metzger here, the Computer Science 2, CS202. Today we're going to talk about static, friend, and enum. So, the static keyword is used to control whether an object, how many times an object can be used or where it can be used, depending on whether it's used inside or outside of a class. So, let's talk about the first case. We're going to use it outside of a class. Now, any kind of local variable is normally has a lifetime of the function call, right? So if you call a function and you declare a local variable, then as soon as the function leaves, then that variable goes out of scope and its lifetime also ends. But maybe you'd like to have a variable in there that does some kind of initialization first. And then every subsequent time you call that function, it doesn't have to reinitialize this resource. Well, what you can do is you can use the static keyword, and it means it's going to keep its value in between the calls to the function that it's located in. And what will happen is it'll be initialized one time when it first gets used. So this is different than a static global variable, which is going to be outside of the function that it's inside. And but the main goal here for using static is to make sure that the variable's linked internally. In other words, inside that C++ file, it's the only place you're ever going to see that variable, or inside that function, it's the only time it's ever going to see that variable. And therefore, you can't get access to it from another compilation unit, another C++ file. So because of this property, they have a lot of use, as I said, for having an initialization step and then keeping track of data. Okay, so if you needed, on the other hand, if you had a global variable and you wanted to see it outside the file, instead of saying static, when you write a declaration for it, you would say extern. So in this line here, extern int x, it means that there is a variable, a global variable called x, that's an integer that's in some other unit. Now, generally speaking, when we're using static outside of a class, we don't want to use the keyword static. We want to use an anonymous namespace instead. So an anonymous namespace is just using the keyword namespace. Don't put a name, put your curly brackets, and then you define your variable inside of there. Okay. So next up is using static inside of a class. So when we declare, when we use the word static, it can mean that we're applying it to a function or a member function or a member variable. So let's talk about member variables first. Those are going to be shared between all the objects of the class. And that means that you're going to need to declare it inside your header file, and then you'll define it in the C++ file. It's very easy to forget to actually make the definition, and then you only have the declaration. So we often use this for class bookkeeping. So maybe we have a counter that we need to keep incrementing for all the classes or something. So this is going to be linked externally. So you have your declaration in your header file, but it needs to be stored in some C++ file, and we don't want multiple copies out there, or we'll get link errors. So that's static member variable. The static member function is something that we can call directly without going through an object of the class. So if our class was named foo and we had a member function called static member function and that was declared static, then when we call it, we just say foo : static member function. And this can only access static member variables. So if you had an instance of the class, then there's no like, you don't know which instance you're talking about. So that's why it doesn't work. That you can't just think that this function knows about the member variables of some other class. So you can only ask us static member variables. Those are the ones we just defined up here, since the other ones only exist for specific objects. So let's take a look at the friend keyword. So let's do a little bit of review. And essentially, if we have private or protected member variables or functions, then we want to, and we had a related class or function that needed to get access to those, then we could use the friend keyword to enable that. Now, you want to use this very sparingly, and use this as a flag that maybe your design isn't as good as it should be. But if you do need to do it that way, in other words, if you said, nope, there's no better way of doing that, then we'll declare it in the header file, or declare that function or class as a friend. And then that'll give the function the ability to get access to that. Okay? Friend is just a declaration, not a definition. So if I say friend class foo2 or something, it doesn't know what foo2 is until it's been defined somewhere else. Okay? Now, you have to be careful with this because friend basically grants. It's grant only. We can't take it away. We can't say, now you can't access my member variables anymore. That can be a problem. So you put this in the first time, and then people start using your library, and then you can't get rid of it. So I would say be very careful using friend. Now, let's talk about enumerated types. So enumerated types are basically integers that have a name inside of it, and the compiler can use that name to allow us to, we can basically use that name as a easier way of assigning values to data. So for example, we have an enumerator here where we have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So in our code, we could say a weekday, today equals Tuesday. And if today equals Friday, then celebrate. So this enumerated types are very useful for making your code spell out what you're trying to do. But you can also do this inside of a class. So if you do an enumerated type inside the class, then outside the class, the type name is going to be class name : weekday, and the values would look like class name : Monday. Okay, so this is a great way of controlling scope, because in this example up here, you notice that the scope is global. So no more can I use TUE or FRI in any other place where this is going to be visible from. So now the enumerator, if you put it inside a class, has the advantage that we can hide it. So if it's public or private, we can hide it or we can expose it. So if we had two enumerators, let's look at this example here. So does this work? So if we have weekday, we have Sunday, Monday, Tuesday, Wednesday, but we also have another one called celestial: moon, earth, Mars, sun. And so this is not going to work because sun is defined twice. And in this case, the values normally start at 0. So this is 0, 1, 2, 3, 4, 5, 6. And this one would be 0, 1, 2, 3. So the compiler doesn't really know what to do with that. But there is a solution for this. And maybe we don't want to have to define a class just to use an enumerator. So what we can do is we can use what's called an enum class. And so the syntax for this is we just say enum class instead of enum. And now whenever we want to use these elements from the enumerator, we can just use the : operator to do that instead. Okay, and this new style is preferred because it's type safe. And that means that even though behind the scenes they're just integers. Yeah, they're just integers, then what we'd like to do is be able to control when they get turned from integers and back. Okay, so they're not really integers, even though they really are, but we want to use this, so we can't say if today equals, that's number 5, right? That would work if you were using an enum, but in this case, we don't want it to actually be the value 5. We want it to be a unique value. Now, if you're just putting an enumerator inside of a class, then feel free to use the old style, because it can be, you know, if you're trying, especially if you're trying to use that outside of the class. All right, so use an enum class if it's outside the class, and then use the best one that you need for inside the class. Although it's better just to stick with enum class. Okay, so the last thing we're going to want to review is overloaded operators. So if we have two objects, foo and bar, and we want to use them inside of an expression like cout f times b, right, then the compiler is going to look for either of two different functions. Okay, so it's going to look for foo : operator star that takes a bar for its parameter, or it's going to look for a global function called operator star that takes two parameters, one for the left-hand side and one for the right-hand side. And so in the member function form, the left-hand side is the object the function is called on. Okay, so if there was ff times bb, then it's going to look for foo, and then it's going to look for bar. And if you had it switched, it's going to look for bar, and it's going to look for foo for this syntax here. All right, so now recall there's two choices, right? So we have the global function and the member function. And so you're asking which one should I implement? So the guidelines is that you should use assignment operators as member functions, okay? And they should return star this. The example is if we had a rational number, then a member variable would be operator plus equals, and we take a const reference to the right-hand side, and we return a const reference or a reference to this. Okay, and otherwise you should usually prefer the global version because this allows for automatic conversion of the operand on the left-hand side. So if we had a rational number, so s, right? So we want to have the number 1/2, and we had cout 2 plus s, then it's only going to work if operator plus is the global version, because if it is a member function of rational, which is not going to find, the compiler is going to look for int.operator plus, which does not exist. Okay, so that is the reason for choosing to use the global version, because we want that automatic conversion. All right, so in summary, we want to use static keywords so we can get that internal linkage, especially for functions, and it allows us to do some nice things with classes. We want to use, when you use block level static variables, they're initialized the first time they're used. If they're declared globally, they're initialized before the program starts. If you have a class static member function, then those are shared among all the instances of that class. And if you have member variables, they need to be actually defined inside the C++ file. And we'll see that in the lab, all right? And just as a review, use the friend keyword to enable access to private or protected members. And we should generally use enum class for enumerated types, okay? And lastly, we reviewed some overloaded operators. So here's some questions for you to answer. Why should you prefer enum class over enum? What kind of data is an enum? And what's the difference between internal and external linkage? Well, until next time, see you later. Adios.